All right, hello everybody. My name is Jack Kang from SiFive. I don't know why this says July. I can promise you it has been updated. And I'm here today to, at the end of the year, we have RISC-V Summit is the big event once a year, and we figure we take the time a little bit to talk about what's happened in this last year. Because what's happened in this last year has actually been a seismic change in RISC-V, in our community, our customers, our partners, and the amount of things that's happening now. I know we say this every year, but it's really going to that tipping point of things accelerating to not just where RISC-V, is the future, but that the future is here. So if we look at SiFive as a company, I think most people should be familiar with us at this point. Over the last 6 years, as we've worked to commercialize RISC-V, I'm happy to say that it has happened. So if you look at SiFive as a company, we have over 300 design wins with over 100 different customers. These are all RISC-V design wins and RISC-V customers. 8 of the top 10 semiconductor companies are commercial customers of SiFive using RISC-V. Company has grown tremendously since we started. I remember the first RISC-V Summit or a second RISC-V Summit. I mean, it was, the whole summit, everything was like, a fourth the size of this room. Versus where we are now. 500 plus employees, and you can see the valuation, which is really a reflection of what the markets think about the potential of RISC-V. For everybody here, all the participants at the summit, what does the market think that this is a serious, it's real, it's gonna grow, and that's what that valuation reflects. So last year, we really talked about how the future of RISC-V has no limits. And really now, the future is here. So we looked at what happened. It's used across the board. We have over 3,000 members in, I don't know why it does it, sorry. In RISC-V International, it's a platform of choice in multiple geographic locations. In here it says China and India. So you look at that, it's in China particularly, all the new companies, all the startup companies are using RISC-V. They're incentivized to use RISC-V. They're told to use RISC-V. That's where all the funding is going towards, is in RISC-V. Governmental projects, we see this in the US as well. We actually have a talk at the show about CHIPS Act and what that means in terms of US domestic onshoring. All of those things are going towards RISC-V. Right? Sorry about that. All right. Let's see if it stays. All right, platform of choice, China, India, US government. It's taught in all the top universities. I actually have a slide here that shows some of our university collaboration. And this is really important because this is where the next generation of engineers is all coming from. And this has been happening now for the last 5-6 years, and it's growing into more and more universities. And the key thing here is really that, I'm gonna stop. All right, memorize this slide, okay, and then we'll just step forward. I'm sorry. So all the universities have been doing this, but now we're seeing the fruits of that labor, where students are graduating now knowing RISC-V. And whereas RISC-V was being taught at computer architecture classes, advanced computer architecture classes, now they're being taught in freshman level courses and even lower, like pre-university. So how are people learning how to program? How are people learning how compute works? It's all with RISC-V. This is a huge benefit to our industry that the effects haven't even been seen yet. So keep that in mind as things continue to grow. Now, all of that momentum and great ecosystem and things that are happening, that's all great. But in the past, it was really viewed as like, oh, okay, RISC-V is here and the market needs an alternative and it's nice that there's something else and there's something different. Well, it turns out that I like to just say it's just better. You put aside all the nice community things and the nice ecosystem things and the nice that we all get to work together and open standards and all that is fantastic and great and that's the reason why everything started. But then you drill down product by product, head to head with what's in the market today, best commercial products, the RISC-V products are just better. It's able to service more places, has better power, better performance, better area. Right? One area where this is clearly being seen is what we call the legacy efficiency processors. So where is the market focus its energy right now? Especially, to be frank here, ARM is the big CPU supplier. So they're very much focused in very high-end mobile, very high-end data center. In the middle, their cores have not been updated. It's not updated at the same cadence. They're not able to service all markets. This is the problem when you have one company serving the whole industry. It's very difficult and not impossible for one company to service what everybody needs in the industry. With RISC-V, you have multiple vendors, so all of these markets are going to be serviced, and it's a very mutually beneficial thing because as more markets get serviced, more software gets written, and it gets better and better. So here we see in this efficiency space, kind of consumer space, where you need performance but not the highest performance. Efficiency is really the most important thing. There's been no innovation until now. So some of the products that we see, I'll show you some of the data here that we've shared and we talked about. The products here, again, it's just better, right? From an area perspective, from a power perspective, it's significantly, we see 30 to 40% benefit power consumption area, same performance level, right? A lot of this is due to the architecture itself, which brings some inherent benefits that then the micro-architects and the designers can go on top of. A lot of it, is due to the investment that SiFive's been able to put in. The number of engineers that we've had, the years that we've been working on this, to really develop these cores that are very targeted for these markets. So we've moved past, I think the takeaway here is we've moved past where this is a nice community story and there's this nice alternative happening to where it's it turns out that the products are just better too. So when you have those things, that's where you see this unlimited adoption and where the future is so bright. Right? So we have customers today using products from edge AI to client computing, automotive, data center, all markets. SiFive, we're very much focused our investments in higher performing cores, whether that's higher performing application cores or vector performing cores. All right? A lot of new markets are happening. And these new markets, frankly, need this performance, they need the efficiency, they need the vector processing. So we see this in aerospace, we see this in the data center, we see in automotive. All of these are moving to this new environment. Right? And this is also one of those things where if you're in a market where you're developing either your own software stack, or you have control of your own software stack, or you're changing to a new architecture, like automotive, for example, changing to a zonal architecture or central compute, and you're changing your software stacks, and you're looking at what platform do I want to build on, RISC-V or ARM, the choice is very clear, because one of them is an open standard, lots of choices, one of them is proprietary, single vendor. So as long as the performance is the same, and you're doing new software in your control, of course you're going to choose a new one. But now we're saying not only that, but the performance is actually better, which is why we see the shifts here. So SiFive at a glance, we have 4 product lines servicing this. Having the breadth of the portfolio is very important because if we look at modern SoCs, it's not just made up of one core. You need multiple cores, many cores inside the SoC to have a competitive solution. So you need to be able to replace or have RISC-V solutions for all of those sockets within an SoC in order to fully adopt RISC-V. So SiFive, we have our essential cores, so 32-bit and 64-bit, primary embedded cores, real-time cores, microcontrollers. We have our performance cores, which are high performance application processors. We have the intelligence cores, which is focused on vector compute, wide vector, a lot of data processing, good for AI use cases or imaging or anything else where you have lots of data that you have to process. And then we have our automotive product line, which takes cores from the other 3 and makes it suitable for applications that need high functional safety, fault tolerance, not just automotive, but led by that, with essential performance and intelligence cores inside the automotive family. Right? So I won't go over this, but you can see within each of the families, there's many cores inside. Right? And that's part of the beauty of RISC-V is you have all of these cores that can fit the exact needs of your product running the same software stack. Performance family, we've really seen, on the it's just better theme, we have the best performance density. So the area of these cores compared to the competitive solution is significantly less. And then you get second order effects like power and other things. But that compute density really matters, because now you put more cores in the same space, or you can put more performance. We support the latest RISC-V features and standards. I think people at the summit should be very familiar with those, and this is one of the nice things about RISC-V is that it continues to grow. It brings the best ideas from everybody, comes in together, and it goes out as a standard, right? And the standards are built in a way that's additive, so you don't have to throw things away. So that's very, very, different compared to other architectures. Right? We see momentum here. Some of the customers and partners listed. I'll talk a little bit more about that later. So again, compute density matters, not just from a cost reason, although that's the first thing that many people think of, but you get the performance increase, and then you can have more simplified integration. So if we look at the performance family, these are our latest cores. I think we have a talk at the show about this, but the 470 and 670 are cores that we recently just launched. My presentation is screwed up. These are out of order cores. You guys take a quick picture if you walk. It's gonna go, but it's really going from. You can see the applications on the bottom, right? So a lot of consumer applications now are adopting this. Battery-powered consumer applications, things in the home, and then as you get to higher and higher performance, then you get into some of the network appliance, some data center type things. So RISC-V is growing. Our intelligence solutions, so the intelligence cores, again, are the vector-enabled, very wide vector products, very good for data control. One of the really interesting markets that we found that really adopting this very quickly is on the top right there, and it's command and control companion processor. So while the vector cores are very good at doing things like AI, acceleration, matrix multiplication, things like that, it's not as optimal as hardwired gates for your AI thing. And a lot of things in the data center have, portions of their design, which is their accelerator, their AI accelerator is hard-coded. But it's very difficult to program those. It's also very difficult to predict what exact your application is, what AI things you need to run. So usually you're wrong. And you might be 95% right, but there's 5% of stuff that's like overflow that you have to do. So we find a lot of those customers now are taking their AI accelerators, pairing it with our intelligence cores, and then using the intelligence cores to do pre-processing, post-processing, any of the overflow processing that the AI engine could not do in a very efficient way with the vectors. But then these cores are also serving as the control processor. So now they have a programmable solution for their accelerator using standard RISC-V tools. So now it's a single programming stream, can control their accelerator plus the control code. It's very, very efficient. We actually have a talk, SiFive and Google will have a talk tomorrow talking about this exact use case and how the TPU uses it. So I encourage you to check that out. The Essential family, this is the wide range of 32-bit and 64-bit cores. These are the first products that we put out at SiFive. When we started 6 years ago, massive adoption in the industry. I think this has really proven to a lot of folks that RISC-V is real. It goes in production. There's no problems. And it's given people the confidence to continue to increase the amount of cores, the amount of RISC-V usage that they have. We talk about the automotive a little bit. Really here, if we look at where the automotive industry goes, I think it's really driven by two things. So in the last year and a half, 2 years through the pandemic, the automotive suppliers have realized that their supply chain is really important. Whereas before, they were kind of king of the hill and they could kind of dictate to their suppliers whatever they wanted, they found out they had a really hard time getting semiconductor chips. And then they go, you're like Ford or somebody, and you're like, but I sell 7 million chips, please help me. They're like, yeah, well, you sell 7 million chips, we sell 100 million phones. So you're not getting the part. So they've realized that how they treat the industry has to be different, and they've taken a deeper look at this. As they've taken a deeper look at what the semiconductor industry is, they're very worried about their supply chain. And if you look at their supply chain, diversity, reliant all on one single CPU vendor, ARM is a problem. There might be different SoC vendors coming out, but they all have the same core inside, right? And when NVIDIA was going to acquire ARM, or when that was actively going, there was real fear. What would happen? NVIDIA is a major supplier to the automotive guys. What would happen if that key technology is under NVIDIA? So that's caused them to look at things differently. And at the same time, they're going through a shift in their architecture from lots of microcontrollers everywhere to this gateway-style computing, central computing, zonal computing. So it's opened up an opportunity both from the technical side and also from the commercial side. So we see this with not just the silicon vendors serving this industry, but also the tier ones and the OEMs also getting deeper, much deeper into the technology stack to the point where they are fully aware, they're learning, they're eager to learn more about RISC-V and how that can help them solve their problems. So I do think this is going to be a huge area of growth for RISC-V, right? And obviously from a SiFive standpoint, we have the complete portfolio, so not just the main application processor, but also the essential cores, the intelligence cores for some of your data collection and sensing. So being able to do that with options of ASIL-B, ASIL-D, split lock, DCLS, this is, gives our customers choices. The advanced automotive features, so we get to multi-core, multi-cluster systems. Virtualization is very important, so these are things that the RISC-V Foundation is working on, so that we have more and more of these major technologies standardized so that we can deploy it, right? And we see the ecosystem growing every day. So I won't belabor the point because I want to leave time for questions, but this is, the change in terms of the architecture for automotive is driving all of these opportunities across the board with different cores. So the commercial adoption ultimately drives everything that we do, because without the commercial adoption, we can't sustain the companies, we can't grow an investment, we can't hire the team, we can't keep growing all the things. So I'm happy to say that that's all happening. At the same time, RISC-V is unique in how the community enables it to grow. So it's very important to, enable the community to pay back, to serve, to provide for the community, and ensure that RISC-V continues to flourish at different levels. So this is a picture of a freshman class at Rice University. Students are just learning how to program boards. What does it even mean to program a board, right? What does it mean that it runs on the board and not on your PC, and how do you connect it? And you can see that they're working with our Hi-5 1. So it's RISC-V microcontroller that they're using in freshman class, learning how to program. And this really brings me back because I think, one of the first RISC-V workshops, RISC-V Summit, when we had a summit like 2017, was when we launched this Hi-5 1 board. I remember I was the one that launched it, and we got on board, and back then, we were so small and we were scrambling, and I tell you from the time that the wafer came out to us showing up at the summit with the board saying that it worked, it was like 2 weeks. It was like the most amazing 2 weeks. We flew to Taiwan, picked up the wafer, did all this stuff, to now where this board, anybody can just buy it, and universities take it, put it part of their curriculum. It's pretty incredible. Pretty incredible, right? So this is what I talk about when the next generation and how this community grow. In fact, they're going to graduate knowing RISC-V. They're going to want to use RISC-V. That's just the default choice that they're going to use, right? So that's universities. If we look at the professional levels, the developer levels, the one thing we hear the most is, please, 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 can I have more boards? I want to do more software. I want to put it in my data center. I want to deploy. I want to have build systems. I want to write more software. How do I do this? Right? And we've been doing our best. I think the past few years we had our Unleashed boards, we have our Unmatched boards. Every board we build, we sell out. We had supply chain problems. But very happy to hear today to say, talk about our next generation board. It's called the Hi-5 Pro P550. All right, this is the next generation board. We built it together with Intel. There's a talk tomorrow about this. This will be the highest performing, board dev system available. And we are going to build a lot of these so that everybody has access to them, right? Because this helps everybody. We need to have the software written. We need to have more and more software written for this. So we have a talk tomorrow about this. We have some demos of this. If you come to our show floor, you'll see it. This is real. Silicon's already here in a very advanced node. I'll save some of that for tomorrow, I think, for them to discuss. But this is a big step, because now it's not just SiFive building chips and making it, here's a developer board, you can use it, but that partners are coming in wanting to do this. Right? This is the growth and maturity of the ecosystem. Right? So with that, I just want to conclude. I think that your takeaways here is really about where RISC-V was to where it is. And I think in the past, it was very much about what does the future look like? What would happen if RISC-V could do this? And I'm here to tell you that it has happened. It has happened. The future is now. The potential is unlimited because it turns out all the reasons that it happened, all the nice feel-good reasons, those all still exist. But it turns out that the cores are just better. So you combine those two things, and you're just going to see this take off everywhere. So that's really the takeaway that I hope you walk away from these 2 days at the show, seeing the types of companies that are giving the talks. You look at the lineup of keynote speakers, seeing the folks who are going to talk about the different applications that they're using this for. Right, the data center guys. There's a talk by NASA on day 2 about how to use the SiFive products, for all the next generation space compute. Right? You look at all these talks about where it's going, and I hope you walk away with like, oh my goodness, this is more than I thought. This is faster than I thought. But then why? When you look at why is the reasons, I think this is where, I guess I'm talking to press folks here, right? Why is it happening? Go deeper than just like, well, ARM's whatever, and RISC-V is this nice alternative. It's actually more than that. That might be why everybody started looking a couple years ago. But you dig deeper, it turns out that things are it's just better. I mean, NASA's not trying to save a few dollars when they're designing, the next gen space flight computer. It has to be the best. And that's really where we're at. So with that, I think I have a few minutes for questions. He's coming at the mic, sorry.
So, Kevin Creel from Tirias Research. Considering your quoted advantages over ARM, would a software layer emulation of ARM instruction set running on RISC-V be more efficient than an ARM core?
So the answer to that, like most things, is it depends. How efficient is your emulation, and how much better is the core? So whenever you emulate software, you pay a penalty, regardless of what it is. So what I believe is going to happen is we're going to have some emulation in the beginning as people developed their stacks as proof of concepts, making sure that it works. But ultimately, these stacks will all run native on RISC-V because you want the best product with the best core. So as the hardware continues to show its advantages, we will see all these softwares get ported natively to RISC-V. So then that will kind of go away. If you talk about things like, I guess if I just jump ahead here, you're probably talking about, what does mobile look like? What does the App Store ecosystem look like? What does Play Store look like? So I think that's very interesting where if you look at something like the Play Store and the thousands and thousands of apps that they have, it's really segmented in there's a very small percentage of apps that are very compute demanding that most people use, that are updated all the time. So think like maps, for example. Those will get updated all the time. Those will all have to become native. Just because they have the ability to become native because their performance is important, because they're being updated all the time. Where you need compatibility are like apps that are not updated very often. So think if you had a garage door opener app. That app probably is done once and never updated. But that app does not require much performance. So I think we'll see applications like that, like the garage door opener, will just be emulated for compatibility, because performance doesn't matter. But for all the ones that performance matters, all the things that you see every day, those will all run native. And I think those are things that are happening now. I probably shouldn't say more than that.
Well, I mean, the example is Apple, because Apple migrated from PowerPC to x86, x86 to ARM, using a bridging emulation period of time. And then if you talk about data center, aside from cloud guys who recompile everything, anyway, but data center itself have a lot of legacy apps that.
Yeah, no, I think Apple is a great example. Yeah. Not even from like PowerPC to Apple to ARM, for example. If you look at what they did with their watch, they migrated from 32-bit watch to 64-bit watch seamlessly. You actually didn't notice. Consumer didn't actually notice. So they had to do a lot of work with technology, like you mentioned. There's a technology called Bitcode because they have their own app store, they're able to run it. They can actually dynamically recompile at the store for your actual device. So there's a lot of ways that you can do this, but I would say that there's really two parts here. There's compatibility and there's performance. So I think a lot of this solves your compatibility issues, and that technology is well known. And then this is where having more efficient cores, maybe you zero out that effect. But again, these are applications that should not matter as much. The applications that really matter will run native because you want to have that 30% better power efficiency. You don't want to spend that on the emulation.
Thank you for the nice talk. It looks like there are major efforts of RISC-V community is spent on developing the application level performance cores these days. But looking at the example of the ARM, there has been a lot of investments for creating the ecosystem or a lot of applications that are compatible in those spaces. And it took a long time for them to get to that door. Do you think RISC-V is stable enough or mature enough to get to the door as a lot of vendors are hope to?
Yeah, I think definitely it's stable enough and mature enough. Now, don't get me wrong. There's a lot of work that we all have to do. Now, the good news is we get to all do it together. So I think because of that, it's going to happen much faster than it did for ARM. But there is work that has to be done, and it has to be done by companies and the community. Right? It's not any one company, right? I'm not standing up here saying SiFive can do all this by ourselves. Actually, very far from that, right? You look at automotive, all of our automotive partners in the ecosystem developing their stuff for automotive, very important. Having tier ones, having OEMs, having chip vendors developing the SoCs for automotive, very important. Having others in the RISC-V community developing RISC-V products for automotive is also very important because they need to see a robust community so that they can invest in it. And I think the good news is I think they are seeing it, they are doing the investment. So it's up to us as a community to guide them, and to guide all of that energy so that we can go as fast as possible. Because I think the timing is now, but in terms of products, in terms of the spec, in terms of those things, I think those are all ready. Commercial guys are all ready to do things like that. More questions? So we'll be here all week. We have our booth. Please feel free to stop by, ask any questions, SiFive folks. All the things I mentioned today in terms of the HiFive Pro P550, the NASA, the use of the intelligence core, we all have talks about that during the next 2 days. So please join those. If you can't, please reach out to me or Dave right there. He runs, heads our comms. He can help you with any of that information that's needed. All right? Thank you.